Let's go for the next session. We're going to have Andy here with us with the topic testing Java microservices. And participating with us is going to be the Bangalore JUG, and the sponsor will be Tomitribe. So Tomitribe is going to release one of his first products called the TribeStream API Gateway. The gateway is something that allows you to orchestrate, secure, route, and load balancing microservices. So please join us on tribestream.io to join the beta that we are currently running, and try it out. And please make sure to send in any feedback that you might have for this product that we're launching to you guys. So without further delay, let's hand over the word to Andy. So Andy, you have 45 minutes. Okay. And we'll keep 5 minutes in the end for questions. So please feel free to start whenever you want.
Okay, yeah. But this is the first time I've done this talk, so if it looks like I'm going to be overrunning, just shout at me and tell me to.
Definitely. Yeah. No worries.
Okay, I'll go to my screen share now. Should be this guy. And then I should be able to place my video any second now. And I'll just pop this guy over here. And hopefully you should see me now on the bottom as well. Just makes it nice when the video recording is shown. So, testing Java microservices from unit to deployment tests. This is basically a joint talk, so I've put the credit for Alex Soto on our first slide as well, and you'll see his name throughout the slides. There is a reason for this. This is going to be basically a talk that we're going to be doing at DevOps BE in a couple of weeks' time, and these slides are a shared project, and so we're kind of working together on this. He's not on the talk today, it's just going to be me. Like I said, this is the first time we've done. So who am I? I'm Andy Gumbrecht. As Roberto's already mentioned, I am a Tomitribe consultant developer. So we're both at the same company, brothers in arms. We work on a lot on Apache TomEE. So I'm actually an Apache TomEE PMC member. There's a whole bunch of us managing that project. That is the open source version of the EE version of Tomcat. So if you're interested in that, go and check that out. Alex Soto, who's he? Well, as you can see, he's dad. He's also a Red Hat engineer. I have kids as well, but mine are much older, and if I posted them on my front page, they'd kill me. But Alex is my Arquillian superhero and more, so he is heavily involved in Arquillian and testing, the testing framework, Arquillian. Oops, shameless plug, have to get this in. This is basically the book that we've written together, and this talk is off the back of this book. So everything I'm going to talk about today is in great detail within this book. And you could download the early version of that book if you wanted to, but that's getting published shortly and is for sale on Amazon. So what are microservices? Microservices, obviously, they have to be able to run on a Raspberry Pi. No, that's a lie. That's absolute rubbish. Yeah, micro kind of conjures up images of something really small. It's nice if it can run on a Raspberry Pi, but there's nothing to say that a microservices needs to be, or a microservice needs to be small enough to actually run on a Raspberry Pi. We need to understand the anatomy of a microservice, and I love this picture. Basically, we're still in kindergarten when it comes to microservices. So there's a lot of differing opinions around what a microservice actually is. and so we're learning. There's an initiative, particularly for Java EE, which is now EE4J. We are the micro profile. This is an initiative or a collection of vendors to try and fine-tune what we believe a microservice should be and how we deploy it and how we configure it. And this is an incubation project at Eclipse. So if you just go to Google and look up micro profile, you're going to find a whole bunch of information. You can use the microprofile.io as a landing site. That will link you to all the information that you need, including the Eclipse microprofile incubation website. I'm just going to quickly switch to an IDE. This is not going to be an IDE-based talk, but there's a really very simple project. It's called the TomEE Start project. You can see the URL down the bottom. So this URL takes you to a very, very simple project, and I'm just going to quickly flip to that. You should see my IDE. And this, for me, is basically the beginnings of a microservice. So a microservice is going to be some kind of endpoint, and if you recognize the code here, this is a RESTful endpoint, so path color. There's nothing to say that the endpoint must be RESTful. However, I think the industry has pretty much decided everything microservice oriented is going to be RESTful, and so that's where you really need to direct your focus. So I'll just switch back to my slide. It's going to be over here. So let's start looking at the real anatomy of a microservice. And this is very opinionated. Some people might.
Andy.
Yeah.
Your sound doesn't sound like very good. Do you have any other mic, or try with your laptop mic? I don't know.
Yeah, give me a second. Sure.
Sorry about that.
Okay, how's this sounding?
Seems a little bit better.
Okay, that's the microphone.
Yeah, that's much better. Awesome. Thank you so much.
Okay, I'll fold this one away. This is the one that doesn't work right next to my mouth, and the one over here does. Okay, so the anatomy of a microservice. Like I just said, this is an opinionated view. Some people might have a different opinion. The previous screen kind of says we're still drawing that picture. Even after several years of microservices, we're still drawing that picture, and technology has been established. But for me, it's about resources. So resources, that's my RESTful endpoint for me. And this is, as far as I'm concerned, and many others, the micro in micro profile. So it's not about how big is your application underneath your resource. It's about how big is your resource. It's a surface area of your application, and how much is being exposed to the outside world. So your RESTful endpoint might just be one single RESTful endpoint that takes one single parameter. That's about as micro as things get. And this is what we're talking about when we're talking about a microservice. We have optionally controllers. I'll talk about that in a minute. And our domain. So the domain is where we have our business logic. This is where basically the body of the service is created. This is what is delivering information to the endpoint. We have repositories. Repositories are basically storage. So this could be something as simple as a flat properties file. This doesn't mean it has to be a database, and I've got a database symbol there. But this is basically indicating some kind of storage. This could be an ORM. It could be a simple JDBC connection to a database, whatever you want it to be. It's some kind of storage. And this is usually required to configure the state and provide information to the domain, which then publishes that information through the resource. Yeah, controllers are optional. It's when we're using gateways to external services. So what do I mean by external service? Well, this resource is obviously very, very small. We have one single endpoint, and we need to get that information from somewhere. We're either going to get that from our repository, or we're going to get it through a gateway to an external service, which could also be another microservice. It doesn't have to be a microservice, it could be anything. It could be, for example, SAP. You need to draw information from SAP. You would pull that through some kind of gateway class that you write, and the domain uses the controller, or sorry, the controller uses the domain and the gateway to merge that information to provide the service. So this is basically the anatomy of a microservice. Now, as I've just mentioned, some people might decide that picture looks slightly different to this, but fundamentally this is how every microservice is going to look. You might add a few more bells and whistles and give things fancy names. So let's get on to testing. Testing. What does a microservice architecture mean when it comes to testing? How does our behavior-driven development fit into the testing scenario of microservices? Well, as you can see here, we're still employing all the standard kind of testing scenarios that are present today. Might be missing a few, but basically we're going to be starting with unit tests. You're not going to avoid unit tests in any software that you program. A microservice is obviously not really different. All the components of a microservice, or all the makeup or the anatomy of that microservice need to be tested with standard unit tests. We're never going to get away from that, and we don't want to get away from that. We've got component testing. So component testing is the whole microservice picture. So the previous picture, the whole anatomy of that microservice that needs to be deployed in some way and tested. In the EE world, that's going to be, for example, a WAR file that contains all that information. But we're not talking about just EE. It could be a Spring Boot file that needs to be deployed. But basically, we put everything into the deployment, deploy it, and test against that deployment, and that would be a component test. We have integration tests. So our microservice, so this is like a step further than component test. We have an integration test. So our microservice, as I mentioned, might talk to another microservice. If that's the case, then we need to set up that environment for a particular test so that the two services can communicate with each other, and that's going to be an integration test. We have contract testing. This is basically where we have some kind of broker in the middle that is giving us some canned information or canned requests and responses, and allows us to thoroughly test the interaction between two services. So rather than having a test in one environment and a test in another environment, we use the contracts test as a middleman to tell us that the information that's going backwards and forwards is exactly what we're expecting. And then lastly, we have deployment tests. So deployment tests is fairly typical. We have a WAR file, and we need to deploy that to our application server, and that just needs to run. We need to make sure that one. It's no different with microservices. We might be deploying to something like a Docker container or a Kubernetes cluster or anything like that. But it's still important that we test that process. And so that the last test we have is kind of the deployment test. So all these tests have the same goal. It doesn't matter whether we're testing microservices or we're testing any kind of software. The goal is to ensure the stability and the quality of the product that we're delivering. And it also allows us to continue development on that project. And obviously retesting every time ensures that if we make a change, we don't break anything. Microservices, as I said, are not EE. I'm kind of an EE man, and I put my personal focus on EE and E4J. But as you can see here, we're just displaying a few logos just to let you know that testing microservices is not focused on EE. We're going to be doing Spring Boot. We're going to be doing serverless. We're going to be doing Wildfly Swarm, and of course Apache TomEE, which is just the best. But we're still going to be focusing on normal testing. So we'll just get through the basics of unit testing. I don't want to teach anyone to suck eggs particularly on this subject. I'm sure everyone's familiar with unit testing. We're basically going to be having solitary unit testing and social unit testing. So solitary unit testing is where the tests run in an isolated environment away from everything. And obviously sociable is where we're going to be collaborating with our external resources. So that's going to be more kind of an integration test, but you still have that within the context of the unit test. To do that, we create what we call test doubles. Some people call them test dummies. This obviously looks like a test dummy head, but yeah, test doubles is the official term these days. And we have various different types of test doubles. So we have dummies. These are literally just objects that are placeholders. They just need to be, they need to fill the gap so that we don't get a null pointer. They don't have any functionality. They're just a dummy. I think these days everyone is now aware of mocks and using mocks. It's an extremely powerful feature to use mocks. However, when we're using mocks, we should just be going down as far as we can to the root of our test and only mock the things that really need to be mocked. I've seen people mock literally interfaces and they're testing method calls on their interface, which is utterly useless. You know, you need to be mocking way deeper, so underneath the implementation that you're testing. So if your implementation is of an interface calling some other method or some other resource, that's what needs to be mocked. So not the implementation itself. Deeper than that, the thing that your implementation is calling needs to be mocked. We can use fakes with mocks. So fakes are basically dummy implementations of, for example, whatever it is your implementation is calling. It just needs to be able to call that and get some kind of information back. And so we would use a fake. We have spies. This is basically an extension of mocking where we're actually watching the things that we've mocked, and we can intercept calls that are made to those mocks. So a mock is basically a proxy or a stub created from a real object with interceptors that actually intercept the calls. And so if we add a spy to that, we can say how many times a method was called and what the parameters were passed to it. So we're actually spying on the object and making sure that things are doing what we're expecting to do. We can verify that. And then lastly, stubs. Again, you can use these with mocks as well. You can provide a mock of a stub and basically fill out the extra information of the stub to return canned responses and even store state. So if you want to store, for example, something in a database and you don't want the whole infrastructure of the database, you just want a really short test, then you can stub the method call that persists an object in a database, and you can persist that in the stub itself. It doesn't have to go to a database. It's a very lightweight process, and obviously that's very, very quick. So if I'm talking to the database, that would be slower. Providing a stub allows us to just get rid of the whole database, then just do a really, really quick persistence of something in memory. So yeah, unit tests, no magic here. This is basically the anatomy of unit tests. We have a name for that test. The name should be clear and concise. It should tell you what the test is going to do. Don't worry about the length of the name. Something that's coming up in the future is going to be the ability to name tests with an annotation. That's JUnit 5. But the method name should be understandable. We're going to be using the behavior-driven development, BDD, given when then. That's pretty much the standard these days. And then we're going to be asserting the response for the unit of work and making sure that the response to that unit of work is what we're expecting. I'll just skip back if you're looking at that bottom line, assert that Mozart returns. This doesn't look familiar. This is not Hamcrest. This is not JUnit. It goes. Actually, it's very readable, understandable, and that's because we're using Assert J. Assert J is a whole new train set. This is the best of Hamcrest. It fixes things that are wrong, makes so things that were awkward in Hamcrest. These are fixed in Assert J. So highly recommend you start using Assert J. It doesn't have, you don't have to. This is just an option. This is a suggestion, but it's very powerful. So we'll just quickly delve into Assert J and how it's going to help us in testing. We use static imports. You would use that in Hamcrest as well. It just shortens the context. So when I'm statically importing assert that, I can just use assert that in my method. I don't need the whole assertions dot assert that or the whole namespace here. The assertions in Assert J are going to be readable, far more readable. You can actually look at the assertions at the bottom here, and you can see that just by reading the text, they make sense. I'm hiding that, which is basically saying we're not using equals. So here, it's not quite apparent, but we're looking at Mozart returns, Wolfgang Amadeus Mozart. So we're looking at that string, and then we're using the method reference get name. We don't have to be string based here. So this is a very powerful method where we can say we're not actually using equals of string, we're using equals of object. So we can start to use comparable object types. So the composer get name could return any kind of object, and the check that we make here could be the object that we're expecting to receive. So we're stepping way outside strings or native types. We're actually using object types in our assertions, which is pretty cool. Another nice feature is the testing of collections. So collection testing in standard Hamcrest or standard Java is going to be ad hoc. People make up their own way of doing things. You know, how do we test the contents of an array? How do we test the contents of a list? We make up a little routine, and we do our little assertions within that. Very cumbersome, error-prone, and no standards. Well, this kind of standardizes the way we're going to test collections. So we can chain the methods. So you can see we're operating on an operas list, and we want to make sure that it has a particular size. So the assertion has size 2, but we want to actually check contents of this, and so we can use the extracting call on the method get name to actually get the responses that this list is returning or contains, and then we can do some pretty fancy checking. So this is just one method on Assert J, contains exactly in any order. So we're looking for exact strings, but we're not worried about the order of the strings. We're testing the contents of that array. So that's a really, really nice feature. And another really nice feature is the soft assertion. So when we're generally doing unit testing or we're using Hamcrest, we have a failure in our test, boom, the whole thing explodes, we're done with it. This allows us to do several assertions in one method, so we can literally provide a lambda here, and this is going to be something that contains multiple assertions, and the soft assert means don't fail on this. You know, if this one call fails, don't fail. Just collect that information, and we'll fail at the end after we've done all the tests. So this is a really nice way of asserting several assertions on an object. So rather than creating different methods to assert different methods on the same object, we're actually putting that all in one. We're collecting that information, and we'll fail at the end on anything that's not passing. So that's pretty nice. So all the assertions are in a block. And we're also collecting exceptions. So we don't necessarily want to break on exceptions. Unit tests normally declare something like throws exception, and you would have the annotation process that or look for that. It's not very powerful. If you have different kinds of exceptions that you want to test, then you would have to create test methods for each of those tests. Well, here we can actually test or catch the exception in our Lambda, and it doesn't break the test. The test continues running, and then we can assert that the exception that was thrown is the one that we want. So rather than creating methods, we can just do this with a nice collection of exceptions in the search bit. So that's basically unit testing. We're going to move on to Mockito. So Mockito is one of several kind of frameworks that are useful for mocks. I think Mockito is probably the most well established. As PowerMock is another one that's really quite useful. You can pick a mix in certain scenarios which one you use. I think there's only one downside I can think of to Mockito, and that is its capability of testing static methods is not optimal. Let's say not optimal. However, in a microservices environment, we should extremely rarely be using a static method call. So we shouldn't have any kind of static method. It's all instance objects, and nothing should be static. So we're not going to miss testing static methods in Mockito when it comes to microservices. We can initialize the mocks in different manners. So here we've got the JUnit runner. So you're literally just annotating your test with run with Mockito JUnit runner. And what that does is scans your class for any mocks that you're defining. So basically here you can see there's a mock annotation. So when Mockito runner, the JUnit runner fires up, it's scanning your application for these mocks, and it will inject the email service as a mocked object. So it will create a proxy of that object and inject it into your test class. We can also do that programmatically. So if we don't want to run with Mockito JUnit runner, for example, using a different kind of runner. So if we're in Spring Boot environment, for example, we want to use a Spring Boot runner. If we're in Arquillian, we want to use an Arquillian runner, but we still want to have the ability to use the injection of mocks. And so this is how we do it programmatically with Init Mocks, and it just scans this class, obviously, and injects the email service in here. Or we can use a JUnit rule. So if we don't want actually to be using injection at all, we're just going to be using JUnit rule. This initializes the Mockito environment, basically. And lastly, we can completely forget about annotations of any kind and just create a mock. So this is just going to create a very, very simple proxied version of the email service and assigns it to this variable email service. So those are the various ways we can initialize mocks in our application. I think probably this one is the most useful with the programmatic initialization of the mocks. So how do we use mocks? This is where we start to see the power of a mock. So Mockito.when email.receive body messages with subject my subject. If we read that, it kind of makes sense. What we're saying is when the email receive body message subject called with the parameter my subject, then return this message. This is what I'm expecting to do. So it's very easy to read what the mock is going to do in itself. So we're basically going to record our expectation using a concrete parameter. But if, for example, we don't know what my subject is going to be, or we don't want to be bothered with what my subject is going to be, then we can use matches. And here you see matches for any string. So what we're saying is if the email receive body message with subject is called with any string, then return this message. So pretty useful. No, I'd say extremely useful. So start using mocks. How do mocks help us verify things? So this is a verification of the service that we're using. So you've already seen how to create the mock email service. We're now going to use that mock in the concrete class, which is our invoice service. And our invoice service basically takes our mock and tries to send it. This allows us to use the verify, because the email service is a proxy that's been created by Mockito. Mockito has inceptors all over the place that enable us to check things and check operations that have been performed on that proxy. And so, for example, we want to verify that the email service send message method was called at least one time, or in fact here one time. You can have fuzzy ranges, so you can say at least one time, or fixed numbers. It's also nice to capture the arguments, so we might want to base our test assertion on the argument that was provided. So, for example, we could have something that's generating the email, and we're not sure what and when is being generated, but we can capture the argument that's provided, and we can do the assertion on the argument that's provided. And so, as you've seen previously, we used the mock, we inject it into a concrete class, and then the verification is actually looking at the first parameter and checking to make sure that it starts with invoice. And if it doesn't, then obviously that will fail at it. And the subject is obviously any string. Little bonus track here on JUnit 5. I'm not sure how many of you started to use JUnit 5. Me personally, I actually haven't used it much. I've just started to understand some of the new features. I was at a talk earlier this year before it was released that explained some really, really nice stuff that's coming along. And the biggest and most interesting one is going to be the extension capability. So what we can do is add the Mockito extension, and this allows us to really plug into the entire life cycle of JUnit. So we've had rules and annotations added to JUnit over the years that allow us to basically extend the life cycle of unit tests in some way. Extensions actually wrap the whole thing, so far more powerful than a JUnit rule. We can initialize our mock for each test. So in a standard JUnit for each annotation, we're actually injecting the mock person and initializing it with its response, which we can then use in a test method. So we're injecting further down in our test the actual person mock that was prepared in the for each, so we know exactly what's getting injected, and the assertion is obviously just going to tell us that was the expected response. So component testing. I already explained component testing is a package, everything together. So if I'm running, so it's still isolated, still not collaborating with external resources, but it's my application, and if I have a EE application or a Spring Boot application, I'm just going to be testing that in a standard way that we do that today. Nothing special there. For EE, we have Arquillian as our testing framework. It's an extremely powerful framework. If you haven't touched Arquillian, please do. I can't stress that enough. If you're an EE developer and you're not using Arquillian, then you're not testing your applications the way you should be. We use the Arquillian runner. So this is just looking at the test. We have a test annotation down here that tells us that it's a test class, obviously. So there's nothing fancy going on with the test. We haven't changed how our test or JUnit environment works. All we're doing is adding the run with Arquillian class, and that is obviously going to be in a class path defined in the POM file usually. And this allows us to create our application. And this is done with a shrink wrap. This helps us create our WAR file. We're just only adding the classes we want to test for that instance of the test. But we're basically programmatically defining our web application and WAR file and everything that's contained in that WAR file using shrink wrap. And this is just a really tiny snippet of what this can do. It's an extremely powerful API. You can build your entire web application using shrink wrap. And we're deploying it. The testable false here, so we have our deployment is going to return a web archive, so this is our WAR file. And this parameter here, testable false, means that we're going to be isolated. So there's two ways in Arquillian of client testing. What I mean, client testing is where I want to make a real client call to a real server. We can either have run as client annotation. We can add that to the method down here. And that would be just for that specific test. The testable false is for the whole class. So basically, if I have multiple tests in the class, I don't want to be saying running client, running client, running client. I'm just saying the deployment is not testable. All my tests are going to be in client mode. So what's client mode? Client mode is Arquillian will deploy the application to a real application server. So this is getting close to your production environment. It will deploy the WAR file that it creates to your real application server. And then any tests that we run are going to be run in a client mode, which means we have to make HTTP calls or using the protocol that you're using, but REST is obviously going to be HTTP or HTTPS. We're making that real call across the local network to that application server. So it's a very stable way of testing your applications. You know that that call is going to work in a remote environment as well as it's going to work in a local one. To do that, when the application is deployed, it gives us the web app URL. So, here I'm creating a WAR file, and I have no idea what the application is called, and off it goes. This web URL gets injected into my test class, and then in my test method, I can make a real test call to that endpoint URL. So this application is going to be deployed. It's going to give me the URL, and then I make a real HTTP call to my application. So it's very, very powerful. We can do very much similar things in Spring Boot. So we're just adding the Spring runner in this instance, and auto-wired is Spring's version of inject. Basically, you can use inject as well, but auto-wired is the Spring standard. And then, we would use that invoice as we would in any other kind of test, but it's proxy. So the Spring Boot runner fires up to the Spring Boot application, and the proxy invoice is injected into my application, into my test, and I can then do assertions on that object. We can extend it slightly for specific RESTful calls. So we have Spring runner as usual, but what we've got is the embedded servlet runner being defined on a random port. And we're going to be using the test REST template, which is a Spring wrapper for REST calls. We're injecting the local port. We don't actually use it in this test here, but it's just to show you can inject using various annotations, various environment variables generated by the Spring Boot and the Spring Boot test. And then we can again make an explicit REST call using that template, which returns here a string. Wildfly Swarm is also providing some annotations for the Arquillian environment. Basically, any EE environment is going to be supported by Arquillian. I don't think there's a single EE application server that is not supported by Arquillian. So if you're using your own particular flavor of your an application server and you want to test against it, Arquillian is going to have the support for that. And that test is going to be a simple use. Wildfly Swarm just had one annotation here, default deployment. So it looks at the deployment description on the class path and generates the whole application, deploys it, and again injects the proxy invoice service, which we can test against. And here, Vertex provide their own runner. So if I was using some kind of rule for the test, sorry, I'd need to use some kind of rule for the test because I'm using a different runner than Arquillian. The Vertex runner class is the boss here, but I can still create rules that allow us to use the Arquillian environment for injection. So this just deploys in the before method the vertical under test. I'm not totally familiar. I'm not going to bluff you here. I'm not very, very familiar with Vertex and small analysis stuff. I'm a new guy. But after firing up this vertex server, we need to shut it back down, and so on the after method, we're basically just shutting down that server. Let's move on to REST. So that's pretty much the fundamentals of testing unit tests in our components. But we're going to have this RESTful API endpoint. And it would be nice to have some kind of tool that helps us test that endpoint efficiently without reinventing the wheel. And we picked Rest Assured. It's just a really nice API that allows us to test RESTful endpoints in a standard way. So what does a Rest Assured example look like? This is a Rest Assured example. Again, it's using chain method calls. So it's very structured, very readable. It can use placeholders, so it understands REST from the get-go. So if I'm providing something on the HTTP call, it knows how to do the replacement for the RESTful call. And it uses Groovy Path expressions, or can use Groovy Path expressions in any of its methods to locate information within the objects that I'm providing it. So we can use a domain directly, and here again you can see the proposer placeholder. So this is where I'm going to supply my object, and it knows how to do the replacement. I can use a builder. Using a builder is probably a bit more efficient because it allows me to create the REST call foundation, let's say, and then I can reuse that specification. And there we reuse it. So given this builder basically just sets the base URI, but it can do a lot more than set just the base URI. I could set standard parameters or authentication. I can build any kind of standard operation I'm going to be making for every method call into my request spec builder. And then I just use the builder build as a specification before I make the call. So I'm not repeating the information for every test that I have. The builder kind of takes that boilerplate code and replaces it up. Authentication is obviously going to be an issue. Various methods have been adopted for authentication against RESTful endpoints. So we need to be able to use those easily in our test. And we don't necessarily know what they're going to be, so we need to have a framework that's going to allow us to use all the most common forms of authentication. And it can be extended to use your own kind of authentication if you've made something up. But this is obviously just using OAuth2 access token as its authentication. This is going to be a Spring form, and this is just going to be basic with using a password. So various ways of authenticating your RESTful. So when you deploy your application for testing, you're actually testing it as it would be really tested from the outside. Quite important to do that.
Hey, Handy, just to let you know, you have roughly 10 minutes left. Well, give me a few minutes for questions as well. Okay, yeah. I shall really whiz this up because it's just a huge subject. There's obviously a lot to do. So I'm going to speak even faster than I'm speaking now and carry on. So more features, rest assured. We don't just have to use JSON or XML. So when we have our testing against our RESTful endpoints, we don't have to provide. We can provide our own object. That's what I'm saying. And we have relaxed SSL support, so we don't need real certificates. We can use dummy certificates, and it's not going to fail on those. We have input-output filters and JSON schema validation or schema validation. But we need to be able to do this efficiently in our test environment, and so we start to use what we call here service virtualization, which is a method of proxying the call. So when we're making these RESTful calls, we might be making them to external services, and this is an example of service virtualization in capture mode. So what we're doing is making a real call to a real service on an external network that we need to use in our testing environment. So service A calls through the proxy, so we're actually capturing that information. It goes over the external network to service B, and then service B returns its response, and the proxy captures the response and stores this in scripts.
So what this is enabling us is to capture a real call to a real service. So service B, for example, could be SAP. That's a biggie. We can't fire up SAP for our testing environment, and we really should be testing against our production SAP. And if you can afford a test SAP service, well, you don't need us. But this is a lovely way of proxying that information back to the original service. Now we can move, once we've made initial call, we can move to simulate mode, which is where we no longer require the external network service. So SAP is out of the picture. We don't need a test SAP. We just make that real call once, no load on the server. We capture that information. So now we can go to the proxy, and the proxy will gather the response. And this is obviously the canned response we're expecting from SAP, and returns that through the proxy back to service A. So we can actually simulate service calls using, and we're going to be using Hoverfly. There are various virtualization frameworks out there, but I think Hoverfly is the one that's going to win. You know, please take a look. There's WireMock. I quite like WireMock, but I was introduced to Hoverfly by Alex, and it's fantastic. It's really, really good. It's implemented in Go and has many language lines. So in capture mode, we're going to basically start Hoverfly. We're going to make a call to a real host. We get the response, and then the proxy data is stored. And this is basically what it stores. Very simple. We can see that straight away in JSON file. And so the request and the response has been canned in this file. When we now test against it, we can use the canned file, the canned response and request file in our simulation JSON. So this is actually creating a rule that loads our Hoverfly canned response, simulation.json, and then we can test against it. And so we don't need to test against the real SAP server, we can test against the proxy. Very, very useful tool for talking to external resources. And we have verification methods, so we can verify the request and response. Obviously, it would be pointless if we couldn't actually test and verify the responses that we get. So here we're just testing exactly one request, and an example of testing multiple requests using any body. So we're actually, again, using a fuzzy logic that matches provide us. We can have a similar effect here by using any body. We're not interested in the body, we just want the count of the request. So very, very powerful tool for testing against remote services, and it's one of the main tools that we use for RESTful web services. Integration test. This is now getting a little bit deeper. This is where we need to test against our real external resources, and so we have barriers, and the red here denoting our barriers, and we've already seen this diagram previously. This is the anatomy of a service, but we have this barrier to our repository, and we have this gateway to our external service, and so we need to be able to test those. So we'll do the persistence test first. This is very much everyone's first attempt at doing some kind of persistence. So we connect to our database, clean it all up, do our insertion of data, and then we make our calls. So here, preparing a database, and then we execute some kind of query against that database. And this is very ad hoc and made up. These methods, clear database and insert, but they don't exist. You've made them up. You've done all the groundwork to make sure that database is clean. Here, we're going to provide you with Arquillian APE. So easy, a monkey can do it. I don't know who came up with that name. But this basically allows us to remove a whole bunch of boilerplate code and do things in a standard way. So we're using the Arquillian persistence rule, and we're going to be using dbUnit to populate our database. And so in our before initializer and our test, we can just use the populator, giving it our driver and connection parameters, and then we've provided it with a composer's YAML to populate the database. And so the YAML is loaded, and it populates the database in a standard way. And obviously the YAML, you can edit that by hand and generate that in any way you want to populate the database. So it's a very simple way of populating the database in a standard way. Everyone can understand what you're doing. Afterwards, we might want to clean up. So for example, we're using exactly the same composers YAML that contain that data set. We want to clean that specific data set up. And so we're just going to be, after our test, cleaning the database based upon that file. So we don't want to delete everything, we're just going to delete the data set that we fed it in the beginning of that test. So we're seriously reducing boilerplate code. It supports NoSQL. We can do everything programmatically and get productivity. And we have REST API support and SQL support for DB-Unit and Flyway. Now we have all these services. So we've got multiple applications. So we've got 2 services. How do we work with 2 services? We can use the Arquillian Cube domain-specific language. We forgot that. And basically, we're here creating a test that uses our DSL rule. And we're going to be deploying a Redis database or NoSQL database and binding it to port 6379. So this simple rule here fires up a whole NoSQL database and injects it into our application. We can test against it. And using the REST template, we can make our REST calls. So full Spring Boot support. We're using a custom initializer here. So how is our service fired up? We're talking Docker here, so missed that big point at the start of this. Arquillian Cube is our way of talking Docker and understanding Docker. So when we're firing out of services, we have multiple ways of firing out of services. And here we're using an initializer, and here we're just providing the Redis port and IP address binding for the configuration of a Spring Boot test, so that it understands that that database is at that location and can talk to it. So we can obviously in this method here we can initialize anything we want, ready for our test. Using real Docker deployments. So again, with our Arquillian runner, we're going to build a REST spec builder to a service that is deployed by Docker. So we have a Docker URL. This is the Hello World service, which is exposed on port 8080, and we're going to be using that in our RESTful tests. And then we can just make those calls directly. And that is just defined in your test development. So we'll look for a Docker Compose YAML file, and here you can see the Hello World service is defined. It's a real Docker image. So Docker will fire up that image, and it will bind it to port 8080.
I have 2 minutes left.
2 minutes, okay.
Yeah.
For the last one, I'll skip over really quickly, is contract testing. So contract testing, here we've got the framework packed. Contract testing is packed specification. It's kind of a broker between the services, so it can generate canned responses and requests. And it supports very many languages, and it's a standard. So look up packed specification v3, and you'll understand what packed is and how to find packed files. And the support in Arquillian is through the Algoron project. And this just allows us here to basically use an Arquillian runner to give us the stub server. So packed is basically a stub server that defines the language that a producer and a consumer can read and write to. And we make those calls and we request those calls. And it's kind of an automated way of saying, I'm going to make multiple requests and multiple responses. And they're stored in our provider, crimes contract directory, the any directory, and those contain that domain-specific language for the packed standard. And we can carry, and so we can and make many responses. The last one is deployment. So Fabricate and Arquillian Cube work nicely together. As I was saying, when we test our application, we package our application up. We have our microservices, like a WAR file or a Spring Boot jar file or whatever it's going to be, whatever you define it to be. We need to test the deployment. And this just is another extension that allows us to say we need a Kubernetes for this deployment, and we're going to deploy it under the Kubernetes Hello World endpoint, and we expect to be able to find that at the end. And so a huge amount of boilerplate code is taken away. So we're building a WAR file, deploying that to a Docker image. And that Docker image is going being deployed to a Kubernetes node, and then we're making a real HTTP call to that endpoint to make sure that it was deployed properly. So this is the final kind of step to define deployments. Using a runner, I'm going to skip through this part. That obviously allows us to incorporate everything in our continuous delivery. So everything I've done so far is nothing that we can't employ in Jenkins. So we can build our entire continuous delivery platform of all our testing right through to deployment. And eventually, we'll land on our production. So obviously, we're super, super happy, and everyone's going to be looking for any kind of bugs. And usually, once we deploy the client, we go, "Oh crap, we broke it." You know, we usually break something. So when we're deploying to production, we don't deploy everything. We use Canary Releases. Canary Releases, very, very simple theory is we have our application version 1 deployed, ready, it's running. We don't want to break it, we don't want to touch it. So what we do is we only deploy version 2 of our application at a rate of 5%. So 5% of our nodes out there are going to be application version 2. And if anything breaks, we can roll that back really, really quickly. And this enables us to test everything as a team. So obviously we work with DevOps, we work together with these guys and make sure everything's from the unit test all the way to deployment on our production system is working smoothly. And that brings me to the end of the talk, which is
wow,
almost perfect.
Yeah, sorry. Yeah, thank you so much, Andy, for this awesome presentation. I'm really sorry for hurrying up in the end, but we have a really tight schedule. So I'm guessing that we're not going to have any time for questions since we're like 2 minutes away from the next session. But you guys that are listening to us, feel free to reach Andy on Twitter. He'll be happy to answer any of your questions. Or Andy, if you have time, you can join the live channel on the Slack channel. There was some interesting conversation that was going on over there while you're doing your session. So you can feel free to join and do some comments over there if you have some time for that.
Great. I know it's a lot of information. Again, yeah. I'll go back to the book. You know, if you're interested in this subject in any way, then look out for the book, Testing Java Microservices by Manning. And that goes into all the details, all the code you've just seen there, all in the book. You actually get code, many, many code examples. It's a very thorough investigation of how we're doing testing microservices.